do nothing, bro.
Yeah, right now.
Bro, especially with D'Angelo Russell snitching on Nick Young.
Like
The whole team is like,
You can play the
nah.
brand new guy for
Nick Young is out
Are you
here.
sure you're not playing on the man?
I don't know what's on
Not
that.
eight.
All right, so I want to talk a little bit about structs. So we have, you guys have used variables. We need to learn about structs because we're going to be using structs for making Pong in the future. Structs are basically a way to make your own variable types. So imagine you want to store information about something like we used an example before about like a Diablo character or about like a basketball player or something. To describe something like a basketball player, you could say their name, what team they play on, how tall they are, what their field goal percentage is, their their three-pointer percentages, how many steals they get, all those things, all those interesting bits basically go into a player, kind of like a baseball card in a way, like a basketball card, if there was such a thing, that you could have, that you could just see that would have all of their information on it. And a struct is a way to kind of combine all those things into a new variable type that you can use to just combine all those interesting little variables. So I want to break this down a little bit. It's kind of like a, if you ever have a situation where you need to combine multiple things so you can represent a type, like a basketball player or a Diablo character or Overwatch character, and you want to combine all those things to say like a hero in Overwatch is made up of health, movement speed, abilities, all those things, you might want to consider using a structure. A structure is basically, you create the type. You decide what goes into a structure. After you create the structure type, you decide what types of variables live inside of it. So I'll just go over a few of the things here to describe what a structure is. Okay. So this example is, there's a company out there called Bloatware that makes inflatable objects. And in particular, the objects that they make include a name, how big they are, the volume, and how much they cost. So in this, they might create a structure that defines those three things all at once. And they create this thing called an inflatable. So there's a new keyword here, struct. This thing that says, hey, I want to define a new structure, which means I'm going to say that I'm going to create my own custom variable type. The name that comes after is called the identifier. This is the name that you want to give to your variable type. You can call that thing whatever you want to. This is a keyword here, but this inflatable is whatever you want to call it. And so once you do this, you can create variables of that type, inflatable now. You are allowed to make variables just like you would an integer or a string or a character or a long. You can now make variables of type inflatable. Once you put this somewhere in your file, you can now create those variables and use them like any other variable that you want to. Each one of these variables that you have inside the structure, notice the curly braces kind of define what variables are inside of it. Each of these things is called a member of your structure. So those things basically belong to the structure. That's why they're considered members. All right. Let me show you here. So the breakdown of the actual structure, these are the pieces that you need when you're declaring a new structure. So in this case, you need the struct keyword. You need the name of your structure. You can name this whatever you want to. The opening and closing braces, the members for your structure, and then you need a semicolon at the end to finish it out. Once you have a template like this, you can now start creating variables that use that template. So here are 3 examples of variables with that structure. Literally, this is the variable type, and here's the variable name. There's a hat, a whoopee cushion, and a mainframe type. So how do you use these in an actual program? Let's go over this in a little bit more detail. I want to write an example of how we would do this in an actual game. So pick a game. Who wants to pick a game? Any game. We'll use that as an example here.
Kingdom Hearts.
Kingdom Hearts? Kingdom Hearts 3? Yeah, why not Overwatch? Too much Overwatch. So here, let's just create some structures that define Kingdom Hearts. Is everyone familiar with Kingdom Hearts? Should I pick a more familiar game like Pokemon? I think Pokemon probably is good. How about Pokemon? Pokemon. Pokken tournament? Pokken? No one plays Pokken. Stop joking. No, Pokken is good. There's good things about it. Okay, so let's make a new structure for a Pokemon. Let's create 3 variables that represent a Pokemon. Let's say a name of the Pokemon, right?
Charizard.
No, it's not Charizard, but the things that describe a Pokemon. Literally, here are the members of the structure for a Pokemon. How about a name? Type, level, I like level. And who's one other thing?
Well, type isn't like what kind of element.
Oh, element like earth, fire, or like water. Let's do HP,
Weaknesses?
and then let's keep it simple. Let's just do type as well. Let's make type just a number here. Like let's just say type will be, yeah, like 0 is air, 1 is bug, and 2 is earth, or whatever. You know, we can just imagine that those would be the types. Okay. All right, so let's create some Pokemon, okay? So the way you use your structure is just like any other variable. I'm gonna create something called Pokemon Pikachu, okay? You create them like any other variable. You have the choice of initializing oh, one thing before I get there. This right here, notice where I put this. See where int main is right here? Notice that I put it outside of it main. This is important. Where you put this does matter. Like if you put this outside of main, it means that you can use it anywhere inside of main or any functions below it. So keep this in mind. You probably want to declare this near the top of everything that you're about to use. All right, let's do a few things here. All right, so now that I have a Pokemon for Pikachu, how do I actually set his level and his name and his type and his HP? So there's a new operator, which I'm going to show you guys, called the membership operator, which lets you access individual members of a structure. So if I have my Pikachu right here, how would I set Pikachu's HP here? So I would grab the variable name, and I'll put a dot. And if you put a dot, you'll see 4 little members show up. These 4 members represent the members of your structure. So if I want to set Pikachu's HP like that, maybe he has 40 HP. I could do it that way. Notice the dot here. So this dot is the membership operator, which lets you access a member that lives inside of a structure. Okay. Does this make sense? Anyone have questions on this? Like how does this work? Notice I'm using the variable name here. Yeah, what's up?
I got a question. Would you use the arrow operator?
No, you don't. You only use arrow operators for pointers.
Just pointers, okay.
Yeah, we're not there yet. So we're strictly speaking with this.
I was just curious.
The arrow operator is another membership operator, but it's also a dereference operator too. It's a pointer to member. So this one here, it's all good. No, you should ask. So this is how we access the HP. How would I set his level to be level 1? Pikachu dot level 1. Okay. How would I make another Pokemon? Right? Someone give me a Pokemon to make. Charizard. Okay.
I just say Weedle.
Weedle? We can make another Weedle too.
Magikarp.
It's all about taking the
Something useless.
Mr. Mind.
All right, so we forgot Pikachu's name too, because we have to actually set his name as well.
Mewtwo.
Pikachu.
We have to do it as well.
So even though I called the variable Pikachu, I still have a variable that has to be set to his name. Because remember, you can name Pikachu whatever you want to in Pokemon, right? You can give your own Pokemon a name, like, you know, Troll, or, I don't know, Kappa, Chew. You can name them whatever you want to in the Pokemon game, so there's nothing stopping you from doing that. Also, we need to make sure, we also want to set his type.
Ash, no catching.
Ash no Ketchup. What is Pikachu's type? Mouse?
Electric. What?
Mouse? He's a mouse? He's a mouse type Pokemon?
He's electric.
I know he's electric, but he's also a mouse,
Stay
right?
with the original 150. All right.
Go get crazy.
Yeah, you're going too far.
Alright, so we're going to set his type to be 3. Alright, so we're going to, I've gone off the rails now, completely. I'm just going to name him Charizard. Charizard.
I know you named him that. I know you named him that on the red version.
I'm just filling out a bunch of information for each of these guys here. Maybe he's level, I don't know, 30. Yeah. What type is Charizard? Dragon type? Right? No, he's not dragon. No, yeah, he's dragon type, right?
Yeah, he's fire.
He's fire, but he's also fire dragon.
Well, if you get
Technically, he wasn't dragon
the
until
X,
after like 3rd gen.
That's what I'm saying. Stay with the original.
So he's fire.
150.
All right, we're gonna stop there with 2 because I don't want to really fill out the rest of them. There are other ways you can initialize Pokemon though. Like if I had a Pokemon, let's say Weedle, you can also do this. You can use curly braces to fill out each of his variables in the order that they show up here. You can fill them out down here. So we can do Weedle. We can do his HP is 50 or 20, I don't 30. His level is 5, and his type is Bug 1. So you can also initialize structs this way. I don't really like doing them this way because it's not clear what these numbers mean here. It's not like super obvious. So, but I just want to bring it up that you can initialize it that way because the book brings it up. So look at these right here. All we're doing is we're assigning variables that belong in Pikachu, right? How would I print out Pikachu's HP down here? See how Pikachu? Like this? Dot HP?
Yeah.
That's correct. Because we want just the HP here, right? What about Pikachu's name?
Same thing.
If you did just Pikachu, would it show everything?
No, it would not. Unfortunately, C++ does not work that way. Other programming languages will work that way. You print out just a variable name, it'll just format them all. C++ has no idea what you want to do when you print out that name. You have to actually do every single one of these separately like this. Okay. So that's how you access. A struct is really a way to collect a bunch of information together. So here's my my Pikachu name. His Pikachu, and his HP is 40. Okay. All right. That's how structs are used. Let's do something a little bit more fun, though. Let's not do this. Let's not do this. Let's save this here. Okay. I can create an array of Pokemon. This is my, I'm going to call it a Pokedex. I don't know, how many were there? 151, right?
9
million.
In the original?
151. U2 was just added on at the end, though, so he doesn't really count.
Yeah, it doesn't count. So I have 151 Pokemon in my Pokedex because that's how many elements are in my array, right? So if I just say Pokemon at 0 dot name, does anyone know what Pokemon? Sorry, not Pokemon at 0. Pokedex at 0. Anyone know what the very first Pokemon was in the Pokedex?
The first name was
Bulbasaur.
Bulbasaur.
Yeah, Bulbasaur.
Okay.
Still know my Pokemon. What's up?
Level equals 1. There are that. HP, I don't know, 50. I don't actually know their HP.
13.
13. This type, grass type. This is just comments, by the way, for my notes, so we know. Okay. What about Pokemon at hook at index 1? Who is he? Squirtle, Charizard, or Charmander? Venusaur?
No, Ivysaur.
Ivysaur.
Okay, 13, 40, type grass. And then I'll do a few more here just to get the point across here. I'm creating Pokemon without specifying variable names, and here's what we're going to do. And this is probably Venusaur.
Yes.
26. I don't know what level he went in. Let's do 80.
It's like 27.
Okay. So here are 3 Pokemon, right? So what I can do now is I can use, because it's an array, I can use loops. So remember when we talked about loops and how good they are for looping through arrays of things? If I wanted to, I could also just print out, cout Pokedex at 2, get his name. And that'll be Venusaur, right? Because Pokedex at 2, that's this guy right here, I print out that name. What I can do though is I can print out more than just that. And I can use a little bit of formatting here. I'm just going to do a little bit of formatting. And I'm going to do this like I did before. Remember, these are all structures. So this is, each Pokemon basically has all this information in him. Okay, cool. So I'm going to print out all of Venusaur's information by doing this, by printing out element at 2. So there's Venusaur, name Venusaur, level 27, HP 80, type 6. But because I'm using a structure, all of these live inside a single variable here. And I can use a loop to loop over them 3 times for each of my, and I can replace this. For each of my Pokemon, I can replace this 2 with I. And here. And now, it'll print out all 3 of my Pokemon, starting with Bulbasaur. So here's the output. Bulbasaur, Ivysaur, Venusaur. Okay. Okay. So we're going to use structures more. We're going to be trying to use structures as much as we can. The reason why you would use structures instead of just regular variables, how would I do this without using a structure? How would I create a Pokemon Pokedex? Let's just show you. You guys don't have to follow this, but I just want to show you guys what it takes to do the same thing without using a structure, okay? So I'm going to just get rid of this. I'm going to say I need a standard string, Pokemon name. I need another array for Pokemon level. I need another array, Pokemon HP. I need another one for type. Here, it's going to be an integer, integer. And then for each of these, I have to go here, change that one from name, change this one from HP, one type. And this is what it looks like when I don't do a structure. I have 4 different arrays, one for each type of variable. Now, there's 4 here when I previously just had 1 array. Maybe this seems like not too awful because it's just 4 arrays. But Pokemon have a lot more properties than this, right? If we actually want to start listing off like ability count, what do we want to also call it? Shiny is shiny, right? You can also say is dead. You can also say is flying. I don't know.
They also have the strength and all that stuff to do.
Strength. The hidden stuff.
Yeah, all the stats.
All the stats. I don't know. Vitality, dex. So let's just do these now. Create arrays of all of these. So you can see how this is quickly going to turn into something very unreasonable, because that means that every time I create a Pokemon, I have to basically do each of these things separately. Whereas if I were to use a structure, the structure has all these things in it. So all I have to do is create a Pokemon. And this one array has all those properties in it already. I don't need to do separate arrays for each of those. I just do this. And do and this is equally important for when you're using them inside functions. So we're about to jump into functions. I want to describe functions a little bit more. Because you want to combine all that stuff into basically a little combined description of what a Pokemon is, as opposed to just like blowing it apart and describing each one separately. Okay. Questions? Structures? Yeah.
So when would you use something like this in like a game? So like
A what? Sorry, a what?
So when would you use something like this in a game? Like would
Oh,
it
okay.
be to like just kind of like as like a base stats type of a thing, or would it be like?
Yeah. So we use structures whenever we have. Let's say let's say you want to represent something in a game that you're making, like you're making a new Pokemon MMO or something like that, right? Every time you want to put something into the game, usually that thing that you want to put on is made up of a bunch of properties. If it's a Pokemon, it's like HP and level and name. If it's something like, even something simple like RPG, like let's just take a character in an RPG. Let's say, what have you been playing recently? Your phone? Final Fantasy 14.
Yeah.
You're playing. You take a look at like a spell is a perfect example. A spell is made up of like damage that it does, like whether it is white magic or black magic, whether it has a cooldown, what cooldown it has on it. There are things that you can use to describe a spell that you could use a structure for. So you have like int damage, you have like mana cost, and let's just say cooldown. Let's say those are the three things.
Could crit rate be in there too? Like would like the modifiers be in there?
Yeah, you can do that. And the reason why you do this is because you're going to have 300 spells in your game, maybe more in Final Fantasy. And you want every single one of those spells to have those same properties. The reason is because you're using a spell in more than just one place, because you're in code, what ends up happening is that you end up using this variable type everywhere. So whenever you're saying, hey, I'm about to cast a spell, tell me what the cooldown is. Oh, I can just get it here. Okay, I just cast the spell. How much damage did it do? Well, I can get it from here. How much mana am I supposed to take out of the player's mana pool when I cast a spell? Well, it's right here. Yeah. So you want to just kind of group up all the things that describe an object like that into one structure as much as you can, so that whenever you're using a structure, whenever you're using a variable type, let's just say I have like Kiraga here, right? Or I have another spell which is like Thundara. I don't know. These are Final Fantasy spells, right? I want to be able to describe those things in terms of their damage equals 0. I don't know. Kiraga mana cost equals 100. 5 seconds. I'm just making stuff up here. Thundara damage equals 1500. And this basically forces you to follow this pattern of like, oh, well, I want to use a spell. What things make up a spell? Well, you can see here that I'm asking for these things that describe the spell.
Okay. So it's kind of like an easier way to break down the code into the info you need for that certain.
Exactly. It's all about organization. In theory, you can make a game and never use a struct. Like you can make an entire game and never use a single structure. Just use variables everywhere. And just throw them everywhere. You just basically have single variables like spell damage, like Thundara spell damage. You could do that. Oops. You could do this, and you can make another one that's called Thundara mana cost. You could do that in theory. In practice, this would be almost impossible to actually use because you have 300 spells. and every spell has like its own set of mana cost and damage. In addition, oftentimes you're working with arrays of objects. So you're working with, I have 10 spells in my action bar, right? My action bar has like all these different spells on cooldown I can hit and cast. That action bar doesn't care what kind of spell you have in it. It's literally, the action bar is like, when in code, what you would do is cast spell in action bar 2, actions in slot 2. And the code is written in such a way that it doesn't care what spell you're casting. It just says, okay, you want me to cast whatever's in slot 2, take this much mana, do this much damage, and put it on this much cooldown. It doesn't care because it would just care about using a spell. It doesn't really care about what type of spell it is. And this will become a lot more clear once we do more stuff with game development. It's a little hard to understand and grasp until you've actually used it. But keep in mind that we're going to be using structs and objects more as we do more in the third class, like object-oriented programming. What we're going to do with structs, for the most part, we're going to do things like, for Pong, for example, the best thing we can do for Pong is describe a ball in Pong, right? And a ball in Pong has pretty much like a couple of properties. It has like float for speed in the X direction, speed in the Y direction, and it has a position in the X direction, and it has a position in the Y direction. That's an example of a ball that we were going to be using in Pong. So this will become a little bit more clear as we do more stuff. If you want to learn more about structures, really the best way to do it is to use it in a game, which we're going to do. But I want to jump ahead a little bit. I don't want to like leave you with like a misunderstanding of it, but they're super important and we'll be using them a lot. So okay. Any other questions on structures? Okay. Let's do function review. I'm jumping ahead to functions because functions are also related. You're going to be passing in structures to functions. In addition to passing in structures to functions, you're going to be using functions to make your games. They're very common. So I want to talk a little bit about what functions do. We're going to do a little bit of a refresher in functions, and then I'm going to give you guys lab work and homework as well, so we can do some more exercises in functions. So you may or may not remember, but there's 3 things that you need to do to actually use a function. One is to write what's called the function prototype. The other one is to write implement the function definition, and then 3 is to actually call the function. So here's an example of functions in C++. So I want to go over the different parts here, and then I want to go over how you would use them and how you declare it. This is more of a refresher, hopefully. There's 3 parts, what we just talked about. The function prototype is up here. This is where the function is called, right here. And then here is where the function definition is, where the function actually does stuff. So if you were to call this program, it says, it just spits out this, I am but a simple function here. And the way this thing runs, let's put this into our, let's write this in our program example here. I'm going to write this program right now and show you what happens again. I'm going to delete our Pokemon example, unfortunately. Sorry, Pokemon. So this right here represents the simplest type of function, which is a void function. And we are literally just going to call simple here. And then the function definition goes down here. Okay. So here's the simplest example of what happens when you create a function in C++. So here's where the yellow arrow is. And remember, when you call a function, it goes into that function and starts running what that function is told to do. So in this case, it's running to the yellow arrow. It's inside down here. Let me turn on line numbers here. It runs this and then exits and comes back to where it was before. So functions are a way to write a little bit of code that you can call from whatever you want to. So you can see the output of the code is just this. A simple function. Okay. And the syntax for it can sometimes be a little confusing if you have some parameters that you need to pass in, but I want to talk a little bit more about this. Let's take a look at some more detailed steps about how you actually write a function. Okay. And this is where I want you guys to do lab work, so I have lab work for this. So you can kind of group functions into two categories. Functions that have return values and functions that don't have return values. So functions that don't have return values have a void right here in the function. So looking back at our example here, this right here has no return value. So this function that we wrote called simple has no return value because it has void in front of it. In front of the prototype here, this is the function prototype. This is the function call, and this is the function definition. So in the function prototype and in the function definition, you see that the return type is void. So they'll have no return value whatsoever. In addition, functions that can also take parameters. So this parameter list basically specifies the types and how many arguments you want to pass in to the function. So for example, here's a function called cheers, which takes one argument, has no return value because it has void, and takes a single argument that's an integer, which means that this int expects the cheers function expects to have an integer passed into it when you call it. So there's another type of function which returns an actual value. Let me show you what happens when we do this. I'm going to write this function in a bit. This is actually the lab. So you have the other type of function which actually returns something other than void. So look at the difference between this void function name parameter list and this one, which is exactly the same except it has a type name in front of it. And this thing here, this type name, is the return value that the function has. So let me explain a little bit more about this. I'm going to change this thing from returning void to returning an int, and returning an int here. And this thing, all I wanted to do is I wanted to double the number that's passed in. So we're also going to add in an argument to this. I'll call it int n and put it down here as well. So the parameter list includes an integer of type n, of type int. I'll call it number. Let's delete this guy right here. And all this thing is going to do is what's called a return. It's going to return the number times 2. So let's talk about this some more. Because I changed a lot of things here, I want to describe the breakdown of the pieces of a function. So let's break down this function here into its different parts. So this is our return. This is our return type here, is int. This is our function name right here, right? And this right here is our parameter list. Okay. Those are the 3 parts to our function. return type is important because sometimes you want a function to do some work and tell you about the results of that work. So this return type here is telling me that I want my function to do some work and then return back to me an integer. I'm calling my function simple, and then inside parentheses I have my parameter list. And that parameter list can be any number of parameters that you want to. They will be separated by commas if you have more than one. And whatever you have up here inside the function prototype has to be mirrored down here. So I have the same thing. I have a return type, I have the function name here, and then I have the parameter list down there. So all this function does, it takes the number that's passed in here, it uses the number right here and multiplies it by 2, and it returns the result of this back to the person who calls it. It takes this whole thing and basically shoves it wherever it's been called here. So if I were to call this function simple, what actually happens, it takes this 10 gets put right here, passed in here, into the function, then it returns 10 times 2, and returns that back up here. Returns 10 times 2. So that's what it'll print out. It'll print out 10 times 2. Okay, this is how you make a function with a return value. So here's what I want you guys to do right now in class. I'm going to put this up on Zool. There's a lab and homework document in here. So we're going to do numbers 1, 2, and 3. So literally all this thing is going to do is there's going to be a function, which I want you guys to write, called cheers. And this is actually written already, basically page 281. That takes a single integer argument, and when it's called, it prints out cheers based on a number that's passed to it. So if you have the book, go to page 281, you'll see this. This is the function prototype you should put at the top of your file. And I want you to call this function twice, once with the number 5 and another with the number 100. Okay. If you need examples on how to write this function, just again go to page 281 as well as 282 helps you in the book. All right. And just as an example here, this is just a diagram explaining what happens when you call a function. Again, this is just what I did. There's a function called cube, passing at 1.2. Cube gets passed in, 1.2 gets passed in here, kept as a return value. This is actually the result of 1.2 cube. And then that gets assigned to this variable over here. So whatever you're calling your function, keep in mind that it's going to run off and do some work and then come back and tell you the results of that. Okay. So go ahead and do numbers 1 and 2. 2 is just basically the same thing as number 1. And then number 3 is the final bit of it.
Is it the lab and homework or is it the review?
It's a lab and homework. Yeah. Again, go to page 281 if you are not sure how to write that function. All right, okay. Grab the homework before you go, because this stuff is...
Ready?
Yeah.
Yeah, it would be full.
Oh, sure.
Because apparently an accident, so it's not on my computer anymore.
Oh, really? You can't use a. That's
No, I mean,
weird.
it's completely
This-
gone.
All
I'll make a new folder for you. I'll put everything that's on here.
I already have the sleep post primer thing,
Okay.
so
Well, you can delete it if you want to. So. Here you go.
thank you.
Uh-huh.
So we're doing all four?
Yeah, I mean, we're going to do all four. Just do all three, the first three for now, because it's basically what we just went over. I want to talk about number 4 a little bit before we get into it. So,
Before the homework or anything?
if we don't get to this, yeah, whatever is left over, we'll do as homework. So we'll hand that in next week.
should I have them do each one or one go for
And just do all three and then one. Give me a reminder on how the different parts of a function work. Here's the example of. Here's an example of how you write a function prototype, how you call it, and then how you define it.
No, it works.
So you should have it. Let me see.
Has example of the function. And primer plus book. I will get into explaining why our function is important. Functions are like really the potatoes to the meat that is C++. You get the right idea. Now you just need to write the actual function so that the number that's passed through.
Yeah.
And
Well, so far when I click
Okay,
it,
so
go,
this is number one, right?
yeah, I can do that. Because it's called cheers there. So you look how it's called up there. See the function call? The middle part where it says simple parentheses. Whenever you're calling a function, you have to pass parentheses as well as the number. So this thing is expecting a number to pass this rather than passing the number there where you're calling.
so 5, and then we do it again if it has to be 100.
Yep. So you don't actually need to do C out either. Just remember, this thing is
Oh,
void,
that's
so it
right,
doesn't return anything. So you just call it directly. You don't need to use that. You're right.
Of course, you have a double cube, right?
But it's not written out.
Right. You put double
That's
X in.
part of the end. So there's a formula there. This is why if you look at line 2 of your work, page 31 of the book, you'll find how it's written. See how that thing goes about it?
That's how you have it, right?
No, not void. Double. It's double.
Oh, why don't I have? Oh, you don't have to fucking.
Inside the program you wrote in it, one cube. This one should be
Bring this down here.
No, it's because your function prototype is not before. Look at where the function prototype is up there.
Well, I originally had it up there. That's when it originally.
So would it still be void or would it be?
Yeah, and
No,
also you have extra
it's gonna be a double.
semicolon.
So double's another way of saying it.
Ah, I did. Okay.
Yeah, yeah.
If you're gonna run it twice. That's the one you do.
Okay, yeah.
Yeah.
I've been confused with double.
Yeah, that's essentially that.
Yeah, sorry, the page number up. The top left.
So double and then L cube. And then it'll have
So, why are we even learning this stuff? So why are functions important? Again, it's kind of like it's like a tool you create that you can reuse over and over again. Like, you write something once, you want to be able to reuse what you wrote every time. You might write something super complicated, but you want to be able to use that wherever you're writing your game code. So
Oh wait.
Everything in C++ is practically a function. See how that shares functions right?
Yeah.
Basically, that's what I was. See how that thing takes that variable and
That's, the void cheers is the one on top, right? And then,
this
or
is
is
the
that
definition. That's the definition.
The
prototype's at the top, the definition is on the bottom.
oh,
So follow that exactly.
Oh, that makes more sense.
Are the double return energy right here? So,
It's just A times A times A.
because double?
Because you're actually cubing it. Like a number cubed is a number times itself. Times itself. Yeah.
Okay, so this is.
It should be A times A times A. Like literally just.
You get 125?
Yeah. And then use.
Because you have space. You got this right here, right?
This is a CR?
Yeah.
It's
If it
125.
has a return value, you can use it in like a
Oh, okay, so
CL.
only when it's void that works. I don't know if part of this works.
Right.
And
Only when it's void can you do it by.
And because this is not a void, it needs to have a break tag.
the cube volume of the cube.
Now,
I already showed it for cube form.
Print out one.
Cheers.
Your cheers function needs to actually loop over though. Like I want your cheers function to based on the number that I'm testing. Print out cheers.
Well, you're the double.
So if I type in 5, I want them to print out cheers 5. This I want to print out cheers 100. So inside here, right up loop, right up forward.
so it'd be,
Look at page 281 in the book as well. It'll help you write that function. That's good. Yes. Where's it's in commas. You're
Why would you do cube 5 twice? Oh, 'cause you recall.
Oh, yeah.
done.
It's good.
It's a full.
So yeah, word of advice, if it's void, you cannot use it in cout statements. If it's anything other than void, it means it has a return type, and you can use it in couts, you can use it in assignment operations, you can use it in everything.
so you basically, we don't need,
Not almost. This, you need to put a loop here, not in here. This should be.
Okay.
Look at, again, look at page 281 in the book, it'll help you.
Now it says.
So basically,
I think your USB drive might have a virus on it. I'm worried. I'm worried that you corrupted my drive too.
All you do is just hit C out and that's it.
what for this?
Yeah.
Why do you have cube 4?
Can't grab Zool.
That's fucking.
Oh, this is the one?
That's it. This is like two's not right. And then put that in there.
Cause I didn't do the.
know the answer here in like 2 minutes because we're almost out of time. Thanks. Good. That's it. All right, so let's talk a little bit more about functions. I just want to reiterate what I said. The difference between a function that has no return type, like this, void, is that when you have void as the return type, when you see the word void in front of it, you cannot use it in couts, you cannot use it in assignments. Literally, the only thing you can do with that function is call it on a separate line. It does not return anything, which means that it has to be on a line by itself. That's how a function like that works. If a function has a return type, so something other than a void, that's when you can use it in cout statements. That's when you can use it in assignments. That's why when you have a return statement like this, you also have to return what you actually want to stick back in to the person who's just calling it. So let's go over the answer here. So this is, so I'm doing this. Again, this is what I have as my function, my initial function. You cannot do cout this. The error that it gives you is, hey, I can't convert nothing into something that I can spit out. It won't let you print this out because, again, you can't use this. Likewise, you can't make a variable called like dummy instead of equal to simple. This is also not allowed. Neither of these two things will succeed. However, if you change the return type for something like void to an integer and change this one to an integer as well, and let's just have this thing return 42, now all of a sudden these two things are allowed. Because what happens is that these function calls will be replaced with the result of this function, which will be 42 in this case, like that. All right? So this is how return types work. That's why return types are important. So I asked to make a function called cheers, which takes a single value, an integer, and is a void, like that. So when you call it, it does something with that integer. So I wanted you to call it with 5 and 100, like that. And all this thing is going to do is just going to cout cheers based on how many times you passed in a number here. So this number here changes based on who calls it. So in this case, it's going to be 5 at first, and then it's going to be 100 the next time it gets called. So I can make a loop that doesn't care what that number is, like that. And now my loop will print out cheers based on what this number is. So let's just see the output of this here. Let's create a dummy. So there, called it, I guess, 105 times. Let me just do this 5 times to start. My function gets called 5 times. I can also call it 100 times. There's cheers getting called 100 times. Okay. So again, let's just show what happens to the program when it's running. So here's the arrow, line number 11. Where does it go? It goes to line number 22. N here is 5. Okay, and I is just a loop. It's just looping over this 5 times. So it does this 5 times. Now here's cheers at 100. Now N is 100 here inside this function, and that's what it uses to print out these things. And I goes from 0 2 to 8 to 9 to 10, and so on and so forth. Okay. So as part of this, I want to talk a little bit about this variable right here. This one right here, this argument that's passed in, it's a variable called n. Do you remember one of the rules of C++? If I have a variable called like Pikachu, and he's set to 12 for whatever reason, and I make another variable called Pikachu and I set it to 99, how does this work in C++?
This is the one event laces.
Well, I can't actually create two variables like this. Remember that one of the rules is that you can't have two variables with the same exact name in the same place. So can I do this? I have a variable called n down here. So why is this allowed here? Why is this variable, like if I called my variable instead of n here, I call this one Pikachu, call this one Pikachu, and I make a new variable called Pikachu. Is this allowed? I have a variable here called Pikachu and one here called Pikachu. The reason is it is allowed because where this variable lives is very important. Look at where this variable resides. It resides between the curly braces of 9 and 19. It means that the scope of this Pikachu variable is only between here, where I have highlighted right now. This variable, Pikachu, is within the scope of what I have highlighted down here. So it only lives within 23 and 28 within these curly braces. So even though I have two variables named the same, it doesn't matter because these variables are specific. You can name these variables. You don't have to worry about naming these variables unique. You can name these variables whatever you want to, as long as they are not two of the same in the same function like this. Okay. So let's write the cube function. So the cube function prototype is a little bit different. It takes a double called cube. It takes a double, which is a number. And replace Pikachu with n. And this is my prototype up here. So I'm going to write a function down here, double cube. And all this is going to do is going to return something. Remember, when a function has a return type, now I can use it in part of cout statements. So if I do cout the cube of 5, oops, this is the double. So the cube of 5 is 5 times 5, 25 times 5, which is 125. So you can see here, 125 right at the very end, it prints out. And what's crazy is that I can use this when I'm calling cheers. So if I don't call cheers at all, so if I just make my function, if I just make my program just do this, it literally just print out 125, I can use that when I call cheers. So I just call cheers and pass in a cube of, I don't know, 4. How many times will it print out cheers? It's 4 times 4 times 4. 64 times. What is actually happening with this function? So I'm gonna put a breakpoint here. Look what I'm doing here. I'm calling a function inside of another function here. I'm passing a function result into an argument. So I'm just going to run this here. So here's how this thing resolves. Okay. Make sure I get this. So there's a yellow arrow. The way C++ resolves is it's the innermost parentheses out. So if I were to ask you guys, I'm on line number 13 right now. What line gets run next? Here. I'm calling cheers. This is one function I'm calling. But cheers requires me to pass in a number, and the number I want to pass is this. So if I work from the inside out, where does that yellow arrow go?
It's going to go to cube.
Wait, give me a line number.
28.
Okay. Does that make sense to other people? I'll jump in here. 29.
29.
Okay. Where is this going to go to after it finishes line 30? Someone other than Cody. If I'm done calling Q, what happens after I'm done calling a function? It goes back to where I was before, right? So where was I just now? Where was the yellow arrow here? What was I calling? John. Okay, so yellow arrow's at line number 13. Okay, I'm going to run one step of the program. Where does the yellow arrow go?
Should go to void, or
So which one of these line numbers? I'm about to call this function right here.
the cheers cube by 4.
Right. Does this make sense as to what I'm doing here? Maybe not. Is anyone confused here? Okay. Let me make this. Let me break this out a little bit here. Let's not do this. Let's just do cube. Okay. All right, John. Calling you off. I want you to bring it to the table. I'm on line number 12 right now. Can you see that? What is line number 12 doing?
Is showing the result of the cube, right?
Yeah.
Four.
So what is the result of 4 times 4 times 4?
Which is
64, right?
No, 64.
Okay. So where is that yellow arrow going to go to if I run this right now? I'm on line number 12. Right here.
Where's that line gonna be at?
Yeah.
Would it be in the 20, line 20?
Line 20. What function is line 20 for?
It's trying to define int and
Now, what is the name of that function?
void cheers.
Okay. What function am I calling up here? Can you not? Is it too small? What function am I calling on line 12 here? What's the name of that function I'm calling?
Cube.
John. Okay. So the function named Q. So what line does it go to? You still think it goes to line 20?
No.
Okay.
It should be in double cube. Yeah, double cube.
Okay. So line number.
28,
Okay. Close enough.
I think.
29. Cool. Okay. So it runs that. Where's it going to go to after it calls this? So I'm on line number 31 now. So why did it jump to 28? Can you explain to me why it jumped to here? So I called Q up there. I called this function right here, right? I'm calling a function by its name. I'm calling the cube function. Went down to 29. After I'm done here, see where the yellow arrow is? That's basically what I'm about to run next. Where does it go? Where does that yellow arrow go to next?
Does it go back to line 12?
It does, yes. So if I step one more time, it goes back to 12. Only now it's slightly different. Because what happened was I called cube, I was waiting. I wanted to know what the result of 4 times 4 times 4 is. Now it's figured that out and replaced this. So you see it here as cube 4. But what the C++ has actually done, the compiler has done, is actually replace that with the result. Now it comes back and reassigns that. So it puts that cube 64 into the variable cube result.
So it does it 64 times. Like,
Doesn't do it 64 times. That's just the value. That's literally all it does. That's not doing anything 64 times. It's literally assigning the number 64 to the variable cube result. That's what happened when I called this function. It went and did some work, came back, and told me what the result of that function was. Let's do this again. Now I'm going to put you on the spot even more, John. Okay. So when you call a function and pass an argument with another function, you work from the inside parentheses out. So work from the inner parentheses out. Okay, you do all kind of like math when you're learning algebra. Resolve the stuff inside parentheses first, and then work your way out. So I'm calling cheers is the name of the function. But before I get to that, it's going to call a function called cube. So John, where does that yellow arrow go to?
On the cube, it goes back to double cube. Doesn't it?
Yes, it does. So if I step in, it goes back to line 28. All right? And it also goes back to line number 12. Now I'm back to line number 12. Now I've figured out and replaced that with 64. Right? That's what has happened. This is now, oops. This is now 64. Okay? Now I'm going to call that function. So now where does this line go, John? One final time.
Again with the line 28, right?
What function am I calling now?
Oh,
I worked from the inside out. Now I'm on the outside here. Now I'm calling the function cheers.
it goes to void cheers.
Yeah.
Line 20.
Yes, line 20. Okay. And then does this 64 times and it's done. Okay, so I'm going to put someone else on the spot. Can anyone tell me what that's going to do? Maybe Michael. You want to help me out, Michael?
Sure.
All right, so line number 12. So where does that I had the yellow arrow. It's going to be on line number 12 here. Where does it go to? Can you read that from back there?
29.
29, yep. So I'm going to step in. What is n equal to here? It's 5, right?
It's 125.
5 times, it's 5 times 5 times 5, which is 125. Cool, I'm back. Where does it go to now? What does it replace that cube 5 with?
125.
125, okay, cool. Now what does it go? Now,
It's 29 again.
it goes back to 29, right? Okay. I don't know what 125 times 125 times 125 is, but it's freaking big. Is 191.9 million? That's what it is. Okay. This can repeat. Okay. Let's do this one more time, and I think this should be. I think it won't. Let me shorten this number a little bit because this is going to get really big really fast. Okay. So let's follow this inside out, right? The cube of 3. It goes to line 29 again. 3 times 3 times 3, 27. So it replaces this with 27 internally. That's what you have to think about. Then it calls cube again with 27. Replaces the result of 27 times 27 times 27, which is apparently 19,683.
Yeah.
So it does this. Calls it again, right?
God only knows.
And then that'll be this number right here, which is
A lot.
this is that thing right there. Okay. Okay. Let's add one final bit to it, which is let's call it cheers.
Output cheers that one at a time.
I'm sorry, you don't do this. You can't do output cheers. You can just do that. It's gonna output cheers that many times. Okay. So work from the inside out again. This is how function calls work. This is how nested function calls work. All right. You typically don't do this too many times, but this, doing it once, is pretty common. This is probably the most I'm going to ask you to keep in track of. So hopefully, now that I've gone through the deeper example, this makes sense, right? So you call Q, take the result of it, replace it, and call cheer, right? All right, so I want you guys to do homework, which is lab number, exercise number 4 on here. Write a new program that implements a function called n_cars. Basically, it takes 2 arguments. One is a character, one is a number. And then I want you to implement the function so that it prints out that character that many times. I'm keeping the homework a little simple this time, this week, so you guys can get warmed up. Because next week we're going to do more functions. We're going to do more work on functions. I will talk about recursion, and I will do basic pointers. Okay. So do lab number 4 for homework, and that'll be it for this week's class. Thank you.